Hello. There are certain rules for predicting the product of the nucleophilic addition to a chiral carbonyl compound. So the first rule is the Cram's rule. I already discussed in the last class that the nucleophile is added a carbonyl group which is already connected to a chiral center. See here the chiral center which is connected to the carbonyl carbonyl group is represented by an asterisk sign. So the configuration of that chiral center, suppose it may be S. Then if you are attacking during the nucleophilic addition, there are two possibilities for the attack of the nucleophile to the carbonyl group. First is in the upward direction and the second one is the downward direction. So we know that the carbonyl group is sp2 hybridized and it is a planar structure. So there are two possibilities for the attack of the nucleophile. First is in the upward direction of the carbonyl group. Second one is in the backward, that means downward direction of the carbonyl group. So we will get the two product normally, but one product is major product and the other one is the minor product. Then how we will determine the configuration of the newly generated chiral center? So while we are adding the nucleophile on the carbonyl group, we are creating an additional chiral center in the carbonyl group. So that's why this type of the nucleophilic addition to a chiral carbonyl compound create one additional chiral center. That's why it is known as 1:2 asymmetric induction. And according to the Cram's rule, we have to arrange the substituent of the chiral carbon atom which is already present in the carbonyl group, and we have to classify the groups which is attached to the chiral carbon as small, medium, large. Then we have to write the carbonyl group which is perpendicular to the R, and we have to arrange the remaining three functional group of the chiral carbon atom as small, medium, large, and we have to write the molecule in the Newman projection formula like this. Okay, now according to the rule, there is a two possibility for the attack of the nucleophile to the carbonyl group, which is represented by the arrow mark, and the one is red in color, that is the one possibility for the attack of the nucleophile to the carbonyl group, and the second one is represented by the green arrow. So if you are following the red arrow direction, then the nucleophile will attack in the carbonyl group in between the large and medium group. So we know that there is a steric hindrance is existing. So there is a little chance of the nucleophile to attack the carbonyl group, and the product is shown by the red arrow. So the product is only a minor product because there is a lesser possibility of the attack of the nucleophile to the carbonyl group. Whereas in the green direction, if you are following the green direction, the nucleophile is attacking the carbonyl group towards the side of the smallest group. So the steric hindrance is little bit lesser here. So we will get a product which is shown by the green arrow mark, and that is the major product. And always remember that for any nucleophilic addition to a carbonyl group, the angle of the attack of the nucleophile to the carbonyl group must be in a 45 degree, minimum of the 45 degree angle. Okay. So the final product due to the nucleophilic addition is shown by the green color, that is major product. So here we know that the nucleophile is attacking towards the smaller group side, so that there is a little hindrances occur during the attack. That's why that is the major product. So this is the Cram's rule. I hope that you understood the concept. Thank you.